So about halfway through this video, you may find a promise to record the first half of the video as we neglected, or at least I neglected to press record correctly at the beginning of the session. So we will review what we covered in the first half of the session in this video and splice the two videos together. Here we go with session 3 of our Java additional topics. Let's share the screen here. Java additional topics for FRC. And this is session 3, which originally was held on January 31st. This is now February 1st, and a little recording to fix up what we missed. Our schedule from October to February appears here, and we're now nearing the last few weeks of our sessions for FRC programming. And we're calling it advanced. I just like to think of it as further along the pathway, or bringing it all together during these sessions. We're finding ways to incorporate everything we've learned so far from October until present into usable code to get robots working on the field. Last time we spoke about the robot builder. What is it? How to use it? Generating code for the robot builder. And looking at the command-based code framework that is produced by the robot builder. And we made some connections with PID and with state machines. And we will continue to do this in the next few weeks, bring everything together, as was just mentioned. So this session, it turned out that there was a request for every bot to be discussed, and that's exactly what we had planned. So we will explore some of the every bot code, and then attempt to create a version of the every bot in the code builder, and then import that code into Java, and then do some adjustments to the code to get it working in Java. So that's what we'll have going on this session. And let's get right onto it. Every bot review of the code. So we will just open up another window so we can get an every bot session going on here. The every bot code is hosted on GitLab, which is very similar to GitHub. And like with our VS Code discussions, we dive into the SRC or source directory, main, Java, FRC, and robot. And down in this directory, the every bot code is contained in 2 very simple files. The main file is very short. All it does is call an instance of the robot base. And that is contained in the robot.java file. There we have the every bot code base here. It's a very quickly coded set of commands for the every bot. And there's a disclaimer here. They say that it is catastrophically poorly written. It is not written for a software company. It's written to get students to understand how the robot works and get them started. So this may not meet industry standards for coding, but it will certainly be simplified so that a new student of coding for robotics will have a better chance of seeing the overall functionality of the code. And that's that disclaimer here. So one of the ways in which it is simplified is that it appears all in one file, as opposed to the command-based framework, which appears in multiple files. All right, so here we have the imports section, and we see a number of motor controllers. One of the challenges that we have is that the robot builder program does not have a full list of available motor controllers. We will make some adjustments when we go into the robot builder. And then when we get the generated code, we can go back and modify it and make it all work there. All right, here we are with a few of the things being imported. Some of them will become important later on in the discussion. And an interesting thing to point out, this is kind of like predicting the future as I'm splicing the video together. When we import the motors, we have to remember that not all of them are in the WPI-libj library. For example, the CANSPARC Max is in the com.rev robotics library, as with the Victor SPX. So later in the video, you'll see us trying to import the motors by just changing the edu WPI first.wlibj and then adding a motor on there. It doesn't quite work. So we have to just correctly identify the library in which a particular component appears. Okay, so just like we did before in many of our Java discussions, we import a number of things that are required in the Java program, and then we call an instance of the main class, in this case, robot. We define a few of the motors. And again, here is something that caught us off guard later in the video. Some motors, as it has been my habit anyway, they only require one or sometimes none, depending on, well, anyway, there are lots of different methods available and lots of different programming packages. And it turns out that these CANSPARC Max motors take 2 arguments in their initiation or instantiation. So we have the channel and then the type of motor. So we are getting a little bit of difficulty with that later, and you'll see that the team troubleshoots and is able to overcome this. So here we have our 4 motors. They're defined on channels 1, 2, 3, and 4, and they're for the drive system. Then we have a motor here, which is for the arm, and another motor for the intake. And when I say motor, I'm saying motor controller, as these are the motor controller modules that link the software into the motors. We have a game controller defined on channel 0 here, and then a number of constants. They have to do with the amount of time required to do certain actions, and they are used later on in the robot code. We'll see it in our tour of the robot code here. A few more starting out variables or initialization variables to determine the starting conditions for the robot. Start with the arm up, and we start not in burst mode, and we start without going for autonomous, with these true and false Boolean variables being defined here. All right, so how does the robot begin? It begins with its robot init method, and inside here, we set our left side to inverted and our right side to not inverted. And there is a new method here, burn flash. I don't remember seeing it before. I'll have to look it up in the WPI lib. I believe it may be new. I don't remember seeing it from previous year's work. If you're in doubt about something though, searching for it on WPI lib is a good idea. For example, I could do that right now. I just go here and burn flash WPI lib and see what comes up. So there is some discussion about the burn flash on one of the forums here, Chief Delphi, and then we have, oh, here we are, CANSPARC Max. So it looks like this is particular to the CANSPARC Max motors. Anyway, it is one of the methods available for the CANSPARC Max motors. Let's see what it is. Burn flash. Writes all settings to flash it into the motor. So I guess with the CANSPARC Max motors, then we need to adjust the settings. And that's how we do it with the burn flash. So when we do a setting on the motor, then we make sure that the motor remembers this setting with the burn flash method. The arm is not inverted, and we set it into idle mode. and then flash it, because that also is a CAN Spark Max motor. And then we decide what we're going to do for going for auto. It's either get the go for auto command from the smart dashboard or set it to false. But at the moment, it looks like it's false, but we may be able to set it to true. When we're starting out in autonomous mode, we need to actually measure the time. This auto start is used to get the base time from when we start counting. So at the very moment that we start the robot, it measures the system time. And we had some discussion about this in the main session on Monday night, last night, where we identified get FPGA T or FPGA timestamp as a method arising from some terminology having to do with the computer's circuitry that takes care of measuring time. And this is another method I don't remember seeing before. Maybe it was there. Anyway, I have not used this one. I remember using timer.time or something, or timer.time, something of the sort anyway. We measure the time by setting a variable, auto start, to the system time, and just noting that auto start is a double. And then go for auto, we read it off of the smart dashboard. Okay, how about an autonomous periodic? Well, here, if the arm is up, and if we're in arm up mode, we either say that, well, we're moving the arm up if we haven't reached the time taken to make the arm go up. And so that means we set the arm to travel. Otherwise, we keep it held up. So if we determine to set the arm in arm up mode, it travels up for a short amount of time, and then it holds it up. Well, how much time? Arm time up. And that was previously defined as 0.5 seconds. So I suppose it'll take 0.5 seconds for the arm to go up. Okay, and if we decide to set the arm on down, there's an amount of time taken to take the arm down. We're either traveling down or we're holding it down. And this arm hold up seems to be an amount to keep the arm just held up using the motor controllers. So those ones you may have to tweak for your particular robot, as it says here. Okay, so we are in autonomous mode and we're making a response to the arm. Among other things, it's checking several times a second, maybe 100 times a second. And it goes through all of this code. So right here is checking if the arm's up, we do this. If the arm is supposed to be down, we do that. And we measure how much time has elapsed. And then in the autonomous, there are 3 stages. The first 3 seconds, we are taking out or spitting out the balls for the, probably to place them in the target. And then for the next 3 seconds, that's anything less than 6 seconds, we are driving slowly backwards. And then finally, we do not all that much for the remaining 9 seconds. There's a place where you could set some additional actions and use this kind of pattern, some if statements, to determine the time. And in a future session, we'll see how we can use something other than the time as an indicator as to whether we should switch to the next stage in what we could call a state machine. This is a very simple state machine. It's time dependent, and there are no external sensors required. It just is very, very predetermined. 3 seconds to do this, 3 seconds to do that, and the remaining 9 seconds it will do this until the autonomous time is up. Teleup has a similar init, but it's not used here. Everything is in the robot init. We don't need to do anything particular in the initialization for the teleup, but for the periodic, we have to determine how fast we move forward and how fast we turn. And then we do a little mathematical combination of these two to get the left power and the right power. So you can try this out on your robot with the setup that we have here. And we set the left and right motors to this left and right power amount, and we are basically driving. Okay, so now the controls, you can see we get the raw button. Get raw button is a very useful method for determining input from the driver on the robot program, and each button has a number associated with it. And if you open up your driver station, you can try out these buttons. Something for you to try on your own time, just to see which button has which number. So in your driver station, you'll see that in one of the tabs. And when you're playing with your controller, as you press buttons and move the axes around, you'll see which one is which. So when we press button 5, we want to go 100% intake. And if we press button 7, 100% backwards intake. And otherwise, we just turn off the intake. So we are either pressing button 5 or button 7. And you probably don't want to press button 5 and 7 at the same time. We would be trying to go 100% forward and 100% backwards. That doesn't sound like such a good idea. So we used to code that possibility. And if they're both pressed, we also put it 0. We're just a little bit fastidious about that in certain ways. Just good to consider that possibility that both 5 and 7 could be pressed inadvertently even, and then avoid that situation. You could add a little bit to this if-else structure. The ARM controls, as we already went through the ARM code in the autonomous, it's very similar here. If we determine that the ARM is up, we do the same thing as in autonomous. This is almost a copy and paste. It could be from the autonomous section. So there's the ARM controls, but how do we determine if the ARM is up? Well, here it is. If the ARM is not already up, that's this exclamation mark before the ARM up. If the ARM is not up and we press button 6, then we're going to set the time at which we did a burst. And I suppose that's for making the ARM go up. And then we set ARM up equal true. And we initiate that sequence for half a second to raise the ARM until we get the ARM fully raised, and then it's just held up. Now, at the same time, if we press 8 and the ARM is up, then we're going to move the ARM down. And we take a burst time measurement, get the current system time, and move that ARM down. And then it's taken care of with this last burst time variable in those two sections of code. Finally, when the robot is disabled, oh, this is good, set all the motors to 0. Okay, there's a little tour through the EveryBot code. Though the author of the code is a little bit hesitant about the code, it is clearly relatively straightforward to understand compared to, say, a command-based package, which would be multiple files to leaf through to understand how the code works. So hopefully this is a good introduction for you to start imagining how you can take and even modify this EveryBot code to suit it to your own team's needs. Now let's generate this EveryBot code using the robot builder. Just finding a way to get to the desktop. Okay, here we go. And let's launch the, not the EveryBot builder, the robot builder. We can use the command palette command, Control-Shift-P, and start tool. And there we have our robot builder. And now let's try well, what we can do is look through this code very briefly. This is what we build up with the EveryBot sort of scheme from the software that we just reviewed, but we're going to try it from a new file. So I'm going to go for new file, everybot2, I'm going to call it. And I'll put my previous team number. Okay, so we start with a small tree of subsystems, operator interface, and commands. Let's populate this with various elements. The first here, the subsystems, we're going to need a subsystem for driving. So I'm going to put a subsystem in here, and we're going to call this the drive base. Okay, I'm not going to put anything else in there. And I'll need another subsystem for the arm. And a third subsystem for the intake. Okay, there we go. There are the three subsystems. Now into the drive base. The drive base is going to need, at very least, 4 motors. And let's add a motor controller in here. But in fact, let's add a motor controller group. And we're going to have 2 such groups, one for the left motors and one for the right motor. And now we're going to add some motors in here, a motor controller as an actuator. The motor controller actuator is right here. And we'll put 4 of those in there. Okay, there are 4 motor controllers. Let's name them something appropriate to what we're doing. Well, first of all, the first motor controller group, let us call this left motors. All right, and then we can name this group right motors. We can also see that these 2 items are in red because they need additional items to be complete. In fact, we need to drag some motor controllers into them. So I'm going to call this one left motor 1. And in the spirit of our everybot code, let's invert this one. We'll call it output channel 1, as everybot code also uses channel 1 to beginning. It's counting up the motor channels. So this one we'll call left motor 2. Okay, and then we can go to right motor 1 on channel 3 and right motor 2 on channel 4. The inversion should also be here on the second left motor. And then we can look at, well, what type of motors. It turns out we don't have the CAN Spark Talon, but we have a Spark Max, but we have the PWM Spark Max. That's as close as we can get. It actually doesn't matter which motor we put in here because we can change it in the generated code later. So I'm just going to call this PWM Spark Max right down through all of the motors. And now to assemble the motor groups, I can drag a motor into a motor group. Now the left motors are situated in the left motor group as with the right motors. Once we do this, okay, there we are. There's our motor groups. Now there's something missing. We need to determine that left motor 1 is the first one and left motor 2 is the second one. Same with the right motors. Right motor 1 is the first one and right motor 2 is the second one. There we go. We have our motor groups prepared and they are no longer showing in red, indicating that everything is all right and ready to go. Well, how about the arm? Our everybot had a motor for the arm, and What did it look like? It was a can spark max as well. So let's put a motor in the ARM subsystem. We'll add an actuator, motor controller, and that was, well, we can do our best is the PWM spark max. Let's put that on channel 5 just for fun. And it was not inverted as far as I know, or as far as I remember. And we'll call this ARM motor. Okay. That requires ARM. There we are. Wonder if we should have that. No, it's not there. Okay. Now the intake, it had a Victor. So we'll add a actuator, a Victor motor controller. And let's put that on channel 6. I don't know if that was the case in the code. You can check that later. And there we have it. Okay, our operator interface, well, that will be a game controller. So we'll add one in here. Okay, and there we have it, and it's on channel 0. Okay, now we have an operator interface. And finally, some commands. Well, one of the commands would be to drive. And another command would be something like arm up. And another command could be arm down. We could also have intake. And that's to take the cargo into the robot. Oh, I guess there already is. We could call this intake collect. And we could have one intake drop off. Now, this is not going to correspond exactly with the code we generated in the previous session as I'm regenerating this on the fly, but you will notice some similarities between the code that's generated here and the code that we review in the second part of this video. So what I'm going to do now is generate the code. I just go to Java, and before you know it, for project successfully exported for the first time, open the project directory in VS Code. After that, it's not going to tell you all that much except down here. So you may find that you're wondering what happened when you press the Java button. Well, it already generated the code before you even knew what happened, unless you read the fine print at the bottom. We should now be able to open up this project in VS Code. So I'll open up a folder, and there's the Everybot2 code. And here we are, handy boilerplate code all ready for us to use. Dive down into the source, main, Java, robot directory, and there is a command-based framework for programming the Everybot. Let's look at our commands or subsystems. There's our drive-based subsystem, and there we have the motors in there. That's pretty nice. And there's the PWM Spark Max 1, 2, 3, and 4 channels. They're all set, all ready to go there. Now, what we do have to achieve is to convert these now to CAN-based motors, because the Everybot is calling for CAN-based motors. So we will do that momentarily. Oh, so sorry. Thank you. So we missed a few things here. Maybe I'll have to make a slightly, well, an update video for what we did in the last half hour as the recording was not happening. Thank you very much for that note that we didn't actually start recording this evening. Okay, so we have a few things that are not working well with our code. And it has to do with our, well, Spark, can Spark Max and PWM Spark Max. So we may actually, I wonder if we have to actually restart our, let's see what it says here in our instructions.
Possibly like it doesn't like it that you imported the thing before you actually downloaded it.
So I went to manage or vendor libraries, install new library online, enter the following.
Yeah.
And pressed enter. It didn't tell me here to reboot, and it should have just picked up the library. But this is something that happens frequently. My first tendency would be to restart. And we'll see what happens here. Restarting. Ah, oh, whoops. For a moment, it looked promising. We can go down to vendor dependencies. We've got this one here. Oh yes, maybe we try building it one more time again. There is a place to build here. Build robot code. And what is our...
William,
Yeah.
somebody posted in the chat, like, I think like you may have messed up like the import line.
Oh, thank you. Did I take off one of these?
Like, I think he's just like talking about like when you're actually like importing it in like your code. Yeah, like in the drive base. Like there's just like you may have just like messed up just like possible just like spelling when you were importing new Spark Max.
It's a rev package, not a WPI lib J package.
Yeah, that's the my.
Oh yes, that's it. Thank you so much. So let's go and just double check that. Oh, we can probably find it through our everybot code here. And com.rev robotics. There we are. That's what happened. There we are. Thank you so much. And can Spark Max. There we go. Okay, so that one seems okay. And now our code is much happier with us. Now the PWM Spark Max, I suppose we can do the same thing. Does it take that? Let's find out if there's another aspect to that one. Doesn't seem to like this one now. Actually, we don't need one, but it would be interesting to find out why. Okay, so what was looking for a PWM Spark Max? Oh yeah, we didn't change those to can Spark Max. That's partly why. So I wasn't actually trying to install one. I'm still curious as to why it's not letting me import that. However, we are looking for a Victor SPX, and that's it. Now this one actually may be the CTRE. Yes, so we'll see here, the same thing's going to happen. It's not going to find the com.ctre, so we can go now to CTRE firmware. Don't know if I need to be, okay, Victor SPX, and yes. Software, Phoenix Framework software, there's the installer. I believe this should be it. This is the hopefully the way to do this, I just copied the JSON file address here. And this should be where we get to manage our vendor library, install a new library online, and enter this URL. And try building. So the build did fail, but did it find what it was looking for? So it says the Talon, oh, there's Victor SPX. And it does like the Linux platform. So the Victor SPX is there. Wondering possibly, did we miss something in the file import? Oh, I have lost. Oh, that's why we're in the drive base. Okay. Oh, and it's found it now. Okay, it's happy now. Okay. Now these PWM Spark Maxes can be converted to CAN Spark Maxes.
Is there a way to auto change all of them at once?
Yeah, I should have been doing that. There are a fair number of them, so I can find PWM Spark Max and find and replace. Where is this? Edit, find, and replace. There we are. And this is for all, replace all. Oh, did I get it wrong? CAN Spark Max. CAN Spark Max is okay up here. It finds it.
Needs the one in brackets beside it.
Ah, that's what it is. And we need the one. Yes, thank you. Erase that. Is that working? Still doesn't work. And maybe there's a
It
different
says the constructor is
motor type. Ah, that's it. It's not the same kind of constructor here. And if we look back at this code, I'll bet you we find something like this here. Yes. Okay, so there's the definitions for the Spark Maxes. It's good to be careful with those things. See if it likes this one. Ah, it doesn't like motor type, but it likes everything else. Bet you there's a motor type that's imported somewhere.
It is imported. It is imported on line number 19.
There we are. So that's a good thing to do. If something's not there, look for something that's not imported. And put this in the imports here. And now, oh, it's liking what we have. So,
is there a way inside of WPIlib to just like quickly import something without like just by like if WPIlib does not like something that is not imported, can you just do like the alt enter thing and it will just like automatically import it, or no?
in certain contexts, this quick fix works wonders, but it's very contextual, so it's not always able to work.
Okay.
Maybe someone else here knows some of these shortcuts. There may be some other shortcuts. And there is, of course, autocomplete. And this helps us. If I do this, CAN Spark Max. Interestingly, it's not showing me the constructor for the CAN Spark Max. That would have helped. But we need to know from the application programmer interface that this can Spark Max constructor takes 2 arguments, and there they are there.
It seemed like it was further down in your autocomplete.
Oh, it was there? Oh, maybe I just didn't see it. Oh, that's good. Maybe I should look there. Let's try it with this one. Can Spark Max. Oh yeah, maybe it's way down here. So you see here it has can Spark Max, but there's no constructor in there. So then it leaves me on my own. So just when you think computers are going to work, they sometimes throw us for a loop. All right, our drive base is down to 4 errors. Let's see what some of the other error. Oh, add child. So it's not liking this add a child. Drive base motor, drive base motor 1. Is there an add child here? Motor type, idle mode. Maybe.
Not sure if like add child works with this type of motor.
Yeah, it could be that because, but actually we are, that's the case. Yeah, we're not adding childs here, so that could be what's happening. So we do have to maybe do a little bit of research about whether this add child is going to just work here.
It like my thinking is it probably works for like some motors and it doesn't work, and it probably doesn't work for some other motors.
Just one quick thing to check here. If it's the smart dashboard, no, it's not. So here's an example where it's giving me 3 choices about this add child. Cast argument, drive base motor 1 to sendable, change. So this is definitely something to make a little bit of research. I'm just getting a feeling that this add child method is something to do with the sendable chooser. And again, if we're not sure, we can do the WPI lib.
Might it have something to do with the fact that you're on a command base versus a timed robot? So it needs to know that it's a subsystem?
Yes, and that could be something that we are encountering because there's a different programming sort of pattern to our programming here.
In that second line there, it said subsystem, something about sendable.
Yes.
Subsystem base, it said. If you go back to the to your stack overflow or wherever.
Oh, here.
Yeah, like it said something there. No, back in the back in
or back in here.
Yeah, the second one, subsystem based WPI lib API.
Good. Oh, subsystem base. There we are. And that's kind of strange because, oh, there we have subsystems, but there's subsystem base there. So it's already here in our system, but it doesn't like add child. So what we're adding a child to is not working. Well, there's a good place for us to do a little bit of research.
It had something further down on that subsystem note in your research. It had method, yet it had, yeah, sendable child. Yeah, that. Some days I want to send my children places. The name to give child and then where to send it.
Most interesting. So if we look here, this is the Java code that was generated by our robot builder. It's doing an add child and it was working, we can possibly assume, with the output, the exported code from robot builder. it may be that we have to do a few other things to set this up and get it working. Oh, this one seems to be working. Ah, there it is, because we have motor groups. And we added the entire left side, so maybe we can get away with not adding child this way. Yeah, it seems much happier with us at the moment. So it may be that case, because here we successfully added the child of the entire left side, and here's one for the entire right side. Well, with no errors at the moment, I think that's a good place to stop. I'm going to just open it up for any questions or suggestions or comments. Oh yes, thank you very much, Mike, for pointing out it was a different library. That's great. And as was suggested, we did the FReBot this evening, but maybe there are some suggestions for the next 4 weeks, what we could do to maximize the use of your time while you're here. Oh, there's a hand up, and that is with you.
Hi, William. I was going to use the chat, but I'm not
Sure.
sure if I can describe in the chat properly.
Okay.
You mentioned at the beginning, in the driver station for the autonomous mode, there's some kind of a drop down for a different state.
Yes.
I think because our team is a Rocky team, but when we talked to one of the mentor from the other team, and I recall I overheard that they actually have some kind of physical dial that you can like a switch with different modes. So I'm not sure if it's related to what you described. So
it actually could be that they did a custom interface. They wrote their own window, possibly using one of these systems described in the WPI lib manual. For example, we have, I'm just trying to find the name of these GUI programming systems that you can take advantage of. Advanced controls. No, that's not it. I think one of them was called Glass.
What I do recall, they actually showed us one of the physical, like an electronic component with a dial. So I think I heard something like once in the autonomous mode, you're not allowed to touch the robot. So
indeed,
there's a switch on the robot. You can just dial into a different position. Say if there's 8 position, you can dial 1 position for a certain behavior, 2, 3, 4. So it kind of when you said about the drop down, it kind of reminded me about something I heard in the past about switch. So I'm not really sure if it's the same thing.
Maybe I can show you here something that comes up.
Yeah, that would be great. The driver seat, because I never seen a drop down in the driver's station.
I'm not seeing it here either at the moment. Maybe because I don't have code in here. I wonder if anyone has the driver station on their computer right now. Anyway, I will share my screen and just give it a little idea. Oh, maybe let me just see you on here.
I have driver station if you need it.
Oh, that would be great. Maybe actually it may not be the driver's station. It could be the dashboard. I may be forgetting here.
You're not sharing your screen, by the way.
I know, I'm looking for it here. Here we are. Okay, so I'm just pulling up an image of the dashboard, which it goes along with the driver station. And now I'm going to share my screen. Okay. So here's an image of the dashboard. And you see in this dashboard here, there is a pull down for selecting autonomous. and you can choose your autonomous there. And this may be what you were describing. Is that correct?
I'm not really sure because what I know that they actually have a physical, like a switch.
Oh, a physical
Mount-
switch.
Yeah,
Nice.
like mounted on the robot. It's like a dial or
Hmm.
some sort of.
Oh, okay. So in that
So-
case, they may have that connected up as a piece of hardware that uses some kind of device, maybe a potentiometer or some kind of way for it to read which selection has been made and then set that in the
in the code.
yeah, so that's definitely a luxury item. You can do
Oh,
it
okay.
just as well here, but that sounds really great. I've never actually seen that done, but it sounds like a great project to do.
Yeah, it just
What-
when you describe the drop down, it reminded me about what I heard about the little switch dial thing. So
Nice.
I'm not sure if it's achieving the same purpose.
Yeah, it sounds like it is. It just I've never actually seen that. I see that Yana has a hand up.
Yeah, I'm just wondering what the benefit of that would be, because once your auto mode is over, why you can't go onto the field and switch it again?
Well, actually, the way I imagine it, when you're placing your robot on the field, you dial in a autonomous mode appropriate for your plan for that game, depending on where you're starting and what you want to do. And you just dial it once, and autonomous only checks during autonomous which of the modes it's in. And once it's done after 15 seconds, it doesn't really matter which autonomous mode it was in, because now we're in teleoperated mode.
Oh, okay, so it'll automatically go back to teleoff as soon as your time's up.
Yeah.
Okay, gotcha. But the same thing happens with the selector on the dashboard.
Yes, indeed.
Okay.
So my
Very-
plan,
This year, do you see any need for multiple setups for
Well,
autonomous?
when I saw the field, I was looking at the locations of the balls. I'm not entirely clear. I think the balls started exactly the same spot. If they don't, well, that's another layer, but you may have a slightly different autonomous routine depending on which part of the tarmac you start on. And so, for example,
in order to go and pick up your ball.
yeah. And assuming it's in the same place each time, then from the first tarmac, you have a certain direction. And the next one, well, you have a slightly different direction you have to head. And you have to also coordinate and make sure you don't run into someone else's robot. So maybe you go for a different one of the balls. And so you actually, during your match planning, you may have to describe that plan that your robot has and have an alternative. Maybe someone else is going to get in the way in their autonomous routine. So you might have to make another plan.
Yeah, there's only 11 balls, so it's yeah.
But during autonomous, well, they'll have to be fairly quick to go and pick them all up. And another detail I haven't really studied in the rules, are they interspersed or are they random, or are the teams selecting? I need to read the rules a little bit more clearly, because that would make a difference as to your autonomous routine. If they're in a different place each time, then you're going to want to identify the color of the ball and not deal with the other team's ball.
I believe, if and someone can correct me, but I believe your color ball is going to be sitting in the exact same spot at the start of every match.
If that's the case, then
Mike agrees. Yeah, Mike agreed with me at the start of each match. The cargo
Good.
has the same starting location.
So that makes a huge difference, because that would be a whole other layer of complexity to have autonomous checking for the color of the ball. And it could cause a lot of robot collisions, because what if two robots are getting in the way trying to check for different balls? So that's probably a good thing that they're the same space or same color each match. There
Like
we
an
have
easy
it.
solution, if it was randomized, would probably just be like a color sensor, like somewhere
Yeah,
on on the robot. Like
indeed.
so like that, like possibly like a color, like basically it will check like if the color is your alliance color, then like it keeps
Yes.
it into the robot, but if it isn't, then it will just like spit it out.
Exactly. So you kind of mount a color sensor near the front of the robot. My students also they were able to identify the color of the ball using Python vision processing, and they could separate the ball out. So there are
And also it
different.
did not really like like it would kind of like make sense if it was randomized, because like last year because like in 2020 they also had like a color sensor thing
Oh, yeah.
with like the Wheel of Fortune.
Yes, and that would be a nice handy tool to use. You just have to set it up right and see if you can get it onto the collector or the intake without getting caught in the intake.
Yeah, or probably just gets like put like somewhere like near near the elevator.
Yeah, you'd have to be very strategic and also look at the range of that color sensor. I'm not sure if it was designed for long range sensing. In that case, you may need a video feed.
How does the robot communicate with the station to know what color you are?
Oh, there are, I believe, some items in the application programmer interface that indicate how that's done. And you can actually read whether you're red or blue from your computer program, and then make decisions accordingly.
On driver station, I believe it says it has like a drop down menu, and you can select if you're red 1, red 2, red 3, blue 1, blue 2, blue 3.
That actually helps you. So you select here. I actually have a driver station open right now, and that would be just nice to look at. So here's a driver station. And there's the red 1, 2, 3, blue 1, 2, 3, and you can select that. And then there's a application programming interface means of reading which one you are.
Which
Thank
for
you.
vision.
Sorry, go ahead.
So I was just going to say, which would be helpful if you're using vision processing, right?
Yeah, so that you know that you're looking for red and not blue, for example. There was another question at the moment, or was that you? Yeah.
Oh, I was just, I never pay attention. There's actually a drop down in the driver station at the bottom that you just click.
Oh, yeah.
I will have to do research to see how you incorporate that in your code to,
Yeah,
corresponding to the drop down.
Like the way I would do it, so I would say WPI lib API read team color.
Awesome. I'm thinking that if that could help out like in autonomous mode, just like reading like what position you are on the field. Between, like,
oh yeah,
red 1, red 2, red 3, and blue 1, blue 2, blue 3.
Oh, reading it off the field, that would be interesting.
No, like I wonder if like reading that like red 1, red 2, red 3 would help out in autonomous mode.
Yes, I think
like
so.
Off of driver station.
I don't know if it would, because the driver station is not where your robot is.
Yeah.
So your robot could be not like it could be positioned in some random spot that has nothing, no correlation to your driver station position. At least that's what I think. I don't think you have to position your robot straight ahead of the driver station. I think it could be, as long as it's not interfering with anyone else and has all its wheels on the tarmac.
I missed that as I was just thinking of doing driver station. Okay. Driver station.alliance. There we are. So we can tell which alliance we're on by calling these methods. Get alliance, get the current alliance from the field management system. So there's the command in the application program interface. And the key is to know what one. First I tried check color and there was something else there. I was like, well, what else could it be called? Oh, alliance, let's try that. And it worked. So there we are. Yeah, I would be very appreciative of any suggestions for our next 4 weeks of how we might refine our plans. For the moment, I will continue refining our exploration of the robot builder and doing a little bit more in terms of the state machines and the vision processing and the other things that we've done so far.
Did you already talk about like autonomous, like how to program like an autonomous routine, or no?
I haven't yet, and that definitely can be part of what we're doing. A good place for you to start is actually, maybe you might want to review this one. It is a really great, I'll share my screen here. This one here is a really great example from the Everybot. Oh, where did I put it? Here it is. So here's the Everybot's autonomous. And this is what we do in autonomous. We, under a certain condition, we do one command. And then when another condition is met, then we can switch. And I have some detailed autonomous code from my team last year. And we actually, it was not all timed. It was also based on other factors in the system. So we had variables that kept track of what stage of autonomous we were at. And I'll share that with you in a future session. I'm going to put this down in my notes for next week.
In 2020, like our team, we use like splines for like
Oh, yes.
autonomous. Like
Nice.
how complicated is that to learn? Like, is it like very complicated or no?
I have a feeling the splines you refer to may be sort of XY positions on the field. Is that correct?
I think so. Like that,
Yeah,
like
no.
2020 was like my grade 9 year. So
And there were some examples of those we did just before the holidays in our probably second last or last session before the holidays. We're doing some XY coordinates in autonomous, and we can go and revisit those. I believe they're called trajectories in the WPI lib documentation. So there's a trajectory and a little write-up about it. So you might want to read up about that, and we can do a little bit more. Maybe we can try to put a trajectory into the code that we're writing for the Everybot, for example. So with that, I will suggest we will sign off for this week and be very happy to respond to any emails or suggestions you may have. And it seems that we have occasion to explore more autocode and trajectories and further refine our robot builder code and move towards vision processing by the end of February.
It sounds good.
And meanwhile, we're going to be building the Everybot this weekend, and maybe we'll have a chance to try out some fun things on the Everybot eventually. If you want to write something for the Everybot and see if it actually works, maybe you can actually do that. Well, anyway, we'll see if we can set that up.
We have a build day on Saturday at our school as well. We're going to try it, but we have to do some cutting before that because.
Oh yeah. So hopefully you'll get some cutting done in time there.
the TDSB is like struck with like a cohorting rule where only like people who are in the same class can actually do extracurriculars.
Oh no.
So
you have to have team A.
Like
team
our
B.
season has been slowed down by a lot.
Yes.
Because like we were only able to get like 2 or 3 people in a day.
Wow. Extra special challenges. Right.
Yeah. So it was a kind of slow start to our season because of that rule. It is a very complicated and weird rule that they have because it doesn't happen at lunch. It just happens after school.
Oh wow.
It's all smoke and mirrors. We've been cohorting for 3 years now, basically, and it's been a nightmare. And it doesn't even mean anything because they're all on the same buses. They all eat lunch together.
On the weekend, they're all friends together. But that's another discussion. We really hope that it'll be the best developments for everyone. So we really appreciate your participation this evening, and we'll look forward to seeing you next week. And please feel free to reach out by email in the meantime.
Sounds good. Thanks, Williams, for your time. Bye.
Thank you, William. Bye.
And take care. Thank you, Ryan. Bye, Jan.